Howdy folks, I've got a friend of mine who just recently bought this Twin Reverb at a bargain price. A little bit worse for wear though. Wasn't sounding too good, and so he gave it to me to check over and repair and see what needs doing. So we're just going to go over it right now and check on some things. I've already done a little bit of a look at it, and I can see some things that will be definitely getting some attention. Here's the power transformer, rusty on top, but otherwise okay. There's a lot of this resin and epoxy around the edges where it's melted, likely some overheating. Here's some on here as well, on the choke, which has probably had some overheating. That's the output transformer, looks okay from the top. Although interestingly enough, we can see some different holes here, and actually, no, never mind. My mistake. That's the hole for the cover that goes on top of these capacitors here, which, in all fairness, these are all original here, and these ones have been replaced. But we're going to replace the lot, because this amp is going to get worked. It is going to be used on some big stages across Australia, and it's essentially going to be running at pretty much full volume. So we're just going to replace the lot. These are the originals from 1976, I believe this amp is, or 74. We're going to replace all the tubes, okay? So I'm going to order a new set of 6L6s, and I'm going to order a new set of preamp tubes, 12AX7s, I believe a 12AT7 if I'm not mistaken. 12AX7s here and a 12AT7 here too, but we'll double check and make sure. Yeah, we'll go through all that process together. Now, that's the top of the amp. Let's flip her over, and I'm going to show you what I'm going to do on the other side as well. Alrighty, so this is the underside of the amp. I'm going to start down here in the power section. First thing we're going to do is see these 470 ohm resistors. I'm going to measure them to see how they're going, but I'm going to assume a lot of them are cooked, because they usually are. The 1500 ohm resistors underneath, the smaller ones we can see underneath these bigger ones, they're probably okay, but I like to change them anyway because, again, they're sitting right on top of those tubes, and they're running hot and they're cooking. Coming over here to the bias area, so here's one of our bias caps, negative bias circuit. Cap here going straight to ground. So this doesn't look like a balance circuit. It looks like it's a bias circuit. We'll double check that. There's a couple of interesting wires and bits wrapped around here. I'm going to check and see if this ground point here is tight. It feels like it is. There's a lot of wires running everywhere in different spots, and I'm curious as to what's going on here. This doesn't look standard to me, and it's not a good connection. It's just a mechanical connection, which is fine, but there's no solder anywhere. So, and we got the ground coming from the power, the 240 volts, grounded to this point. And then we've also got our grounds coming off the negative bias, which looks a bit cooked. If we look here, I'll get the torch slightly away. We can see there, right where my finger is, it's all quite brown and disgusting. Those solder joints look like they've been done with a little 20-watt soldering iron from who knows where. The end of the capacitor here going onto the pot looks like it's just soldered on. It doesn't even look like there's a mechanical connection there. We can see the lead is just sitting on top of that solder blob, and that's about it. Okay, that resistor is probably fine, but I will check this resistor just here where my finger is. We will check the value of that, as well as the value of these resistors down here in the negative bias circuit, along with the operation of that cockroach right there. And probably got electrocuted and died right in that spot. Some of these diodes are a bit darker than I'd like to see them, so there's probably a bit of overheating there. Okay, so that's kind of the power section out of the way. If we go up further, okay, now here is the biggest problem that's going to cause biasing issues and other issues. These two brown capacitors here. These are our coupling caps that go from the phase inverter to the power tubes. If there's any voltage leak coming through here, DC voltage, that DC voltage is going straight to the screens or to the grid of all four of these 6L6s. And what that's going to do is that's going to change the bias, and that's going to make the amp run a bit funny. Okay, now the thing is there's some blue capacitors in here, like up here. Okay, I'm going to measure that and make sure it's still okay, but otherwise we're probably likely going to change all these brown ones, because the brown ones are the ones that are notoriously bad. And if I look closer, you can actually see they're darkened, they're discolored. That one's cooking. This one, look, it looks like it's a bit charcoal, actually. This one here's probably fine. This Weimer cap looks like a Weimer. Might be different. Probably going to replace these flappy paddles here that are often notoriously microphonic. And then obviously these two down here, which I showed you to begin with, both of them look a bit like they've seen some heat. They've definitely experienced a bit of charring. The other capacitors that we're going to likely change are these white ones here. Now, most of the time they're okay, but there's some physical damage on one of them. There's actually a chunk taken out of that one. Probably melted with a soldering iron. Compromised? Maybe. Working? Maybe. We'll check that. But we're going to replace these Mallorys. There's another one here, and there's two more up here. And there's some more down here going to the reverb. Okay. Two more there. So that's all going to get replaced as well. Now, looking at some of the other resistors here, these two resistors that are coming off the phase inverter section, they're probably going to get replaced. There's another one under here that's coming off one of the legs of our 6L6. That's going to get replaced. I'm going to measure the resistance of all of these. There's a lead just sitting there doing nothing. So this wire here, because we can see it's a fine, it's not a solid core cable. Okay, let me get the torch out of the way. You can see that that wire is hopefully stuck into that turret hole. If not, it looks like it's just sitting on top with a blob of solder. Hooray for the technician who did that. Now, while inside of this looks fairly original, I'm going to say that it has been played with a little bit. Fender wouldn't have had this leave. You can see really well there that that chunk sticking out, or that chunk missing from that cap. It's just not the work of Fender. Looking at the tone stack, we can see resistors in here, and I'll have a look there and make sure those are okay. Those aren't too vital. The main thing is getting the amp working to the point where it is safe and operating and the bias is biased correctly. These capacitors on here are some vent SK 85 degree. I can't see the value of them. If I turn them over, 47 UF 160 volt. That's too small. It should be, I think, 70. And I'm going to guess, without touching this one, because I haven't discharged anything, I'm going to guess that this one is the same as well, which means it's not the correct value either. So we're going to bring up the schematic for this amp, and I'm going to order some parts, and then tell the customer that the original quote that I gave him is going to increase slightly due to the fact that these caps are also going to need changing, as well as these flappy ones, and this brown one, all the white ones. Not too much more than I quoted him, but also what we're going to do is clean up all these crappy solder joints. So this is what happens when you use a soldering iron like this. Now this is fine for most use. This is fine for this isn't on, by the way. This is fine for soldering little joints like this and putting components in. But when you got to do ground planes, all this is going to get replaced. Well, it's going to get soldered. This solder joint here is just disgusting. This solder joint underneath here is also disgusting. These are unreliable solder joints. They're going to fail. What you want is original style. See that solder joint? Nice smooth blob. Okay, that's standard Fender. This stuff is hack job central. And the person who did this, did the best they could with the tools they have. But you can't use a soldering iron like this. This is 60 watts. It's not enough. You need something that's going to give you more than 100 watts with a nice big tip on it, because you need to be able to have the thermal capacity to put the soldering iron on there, and the soldering iron has to be powerful enough that the chassis isn't going to act as a heat sink and suck all the heat out of the tip. What you need is a soldering iron that can keep giving that power and melt that solder joint correctly. So we're going to fix that too. We're going to fix all this. We're going to tidy up all these extra wires floating around. There's a lot of garbage in this amp. We're going to clean it up. It's obvious that, let me put this soldering iron back. It's obvious that this has been worked on by people who make do, not people who know what they're doing. So we're going to fix all that, and we're going to make this amp work. And when it does work, it's going to rock. It's going to sound amazing. Alright, just showing you what the new array of filter caps look like. I went with F&Ts because they physically fit. They're good capacitors, they're good quality. I've had good experiences with them. These are what I tend to go for. The Spragues are physically too large, especially for these 450 volt 100 microfarad, or even if you find the 70 microfarad ones, they're big and they don't fit in here. And sometimes some of these models, the cover that goes on here just won't fit on there. So I play it safe and I go with these ones, which are just as good quality in my opinion. But anyway, there's the filter caps done. So you've probably seen this 1,000 times. I've done it a few times on this channel. The thing to keep in mind is this is the side where all the dials are. So it's the front of the amp. This is the back of the amp. You have to be careful with the orientation of these caps. So all of them, the positive side faces the front of the amp, except for this last one here, because these two are actually in series. Okay, so this is the positive side, this is the negative side, and you can see there's a jumper joining them here, and there's a couple of resistors underneath. I've gone ahead and measured these resistors, they're fine, so we're not going to bother replacing those, but the capacitors, definitely. And the ones that were in here prior, well, they're in here now. So you can see there was 3 originals. They were the 22 microfarad. They've been replaced with 22 microfarad, 500 volt. Actually, sorry, these are 20 microfarad. Let's see if we can have a good look at that. 20 microfarad, 500 volt. So there's 3 of those, and they've been replaced with 22 microfarad. That's the closest match you can get. And these grey ones here, they don't look original. They're 100 microfarad, 450 volt. They don't look original, but they may well be. But generally with this amp, they're 70 microfarad. Like I said, can't really get those in there these days. So I go with the 100 microfarad ones down here for the 2 bigger filter caps. Anyway, let's flip the amp over and move on with the bias circuit, and I've got all my other capacitors that came in. These orange drops are going to be replacing all the brown capacitors. You can see there's a couple of 25 microfarad 25 volt, they're the little ones. They're going to be replacing all of the cathode bypass caps on the preamp circuits on the 12AX7s, and then these long thin little ones here, that's going to go into the negative bias circuit. And that will make the amp nice and healthy with a stable bias, stable DC voltage, good filtering, good clean, loud sounding amplifier. So let me turn it over and head on with that work. Alright, so I flipped the amp over, and the next thing we're going to do is replace all these brown capacitors, these ones here, which look like they're a bit like charcoal, with these brand new Spragues. Now they're a 0.1 microfarad 600 volt, and that's what these are here, 0.1 microfarad 600 volt. Alright, so I got all these brown capacitors out. These are the old little turds that don't make your amp work nicely. From the top here we can see we've got the nice orange drops in place, and then the two important ones, as I mentioned before, down here, the coupling caps from the phase inverter to the 6L6s. Next step, I'm going to take out these crusty electrolytic caps here. Some of them are okay, but like I said, you're here replacing them, you might as well do the lot. Alright, now we've taken these old Mallorys out. These are originals, and we've replaced this one here. Now, that one there is a 5 microfarad 50 volt. The one in there now is an 8 microfarad 150 volt. This is part of the tremolo circuit. You can see the roach there, the little tremolo optic, what do they call them? Optocoupler. So we'll see how the tremolo works, or the vibrato, I should say. Sorry, the vibrato. Now that I've gone from a 5 microfarad to a 8 microfarad, it doesn't sound like much, but it could make a difference. And if so, I'll put the old one back. Now the problem with the old 5 microfarad, I couldn't find one that was 5 microfarad. And the problem with the 5 microfarad one, yeah, this one here, see how there's a blob of, let's focus in on that, see how there's this big blob of solder on this terminal here? Well, it turns out that that terminal is actually broken, and it was just kind of soldered back together. It wasn't even a J-hook. So, unfortunately, that means that that cap is, you know, I mean, I could resurrect it, I could put a J-hook there, and I've got a pile of offcuts here from other terminals that I could just fix up and do that. So that's not an issue at all. However, yeah, we'll persevere anyway. So having a look at the amp now, we've done our orange drops. There's our 8 microfarad, part of the vibrato circuit. There's another orange drop. There's a 25 microfarad 25 volt just in here, hiding under there. Here's another one here. I'm going to dress that lead a little bit better. Here's another one here, and I think that's it. Yep, that's it. So we'll go through, and next thing we're going to do, I'm going to fire up the big soldering iron, because we're going to be doing the bias caps. And the problem with the bias caps is, well, one of the issues with the bias caps is that they've been kind of bodgily soldered onto this common ground connection. Well, problem number one is this is just brittle, disgusting solder blob, and the standard ones should look more like that. You can see the difference there. Hack job, proper job. We're going to tidy this up. We're going to tidy this up definitely, because that's our negative bias. This is so important right here. And look, you can actually see the terminal right there. Like, it's not even in the solder. It's kind of just resting on top with a thin sheet of solder. And solder is soft. And finally, this terminal here that runs under this board is actually the positive terminal for our negative bias. And as we all know, if we've watched these videos and many others online, negative bias, positive faces ground, negative faces your bias, because, hey, it's negative bias. It's minus voltage, minus DC voltage. A bit more tidying up to do, and then we're going to fire up the amp and test it out. So stay tuned for that. Alrighty, so I got the amp all done. And what I ended up doing, I didn't end up even bothering fixing up these joints here. I just didn't even use them. So what I've done is with the bias, I've just J-hooked them to each other, going to ground, which is going to this terminal. I'll make sure that's nice and tight in a moment. For now though, I've turned the amplifier on, so you can see it's powered on. No tubes in it, and the reason we do that is we need to check for bias. We need to check for voltages, and we need to check for bias. So I'm going to go through, the first thing, the most important thing, is check for our negative bias to make sure that's working. Okay, so I've got my meter set to 1000 volts. I can set it to 200 because I'm only checking negative bias. We're probably looking for a range of about 50 to 60. So what I'm going to do is I've got one probe connected to ground, that's to the chassis here. And the other probe I'm just going to put on the negative side, which is right here on this pot, and I can also measure here. And then I'm going to measure to make sure that that negative bias, that voltage, is reaching the tubes. Okay, so we're going to look at the grids on here, and I'll tell you which pins they are in a moment when I look at them. So first things first, I'm going to put my probe here. We can see we get a negative bias voltage of 57.1 volts. Okay, now if I put it on this end of the pot here, the negative bias pot, okay, that makes the adjustments. We can see it's 55.3, so 57.2. Now this is with no tubes in the amp, so voltages are going to vary, but right now we don't want to put tubes in the amp because if there's no negative bias, we don't want tubes going up in smoke, especially not brand new ones. So we can see that that seems to be going okay, and then we'll check the other side of this pot as well, which is just through here. So it looks like this is a balanced circuit. 56.9, 55.1. So it looks like it's a balanced circuit here. We'll just double check that that is the case. I'll look at the schematic to make sure, because if we follow this here, let's have a look at the pot. So on the pot here we have 3 terminals. Let's move this out of the way. This white wire comes out and it goes to this point right here in between our 2 little resistors here. Let's keep going. Let's look at this point up here on that cap. Negative 56. So far so good. Okay, right now the amp is fully standby. I'm going to turn the amp on and we'll flick that switch. And I've got my probe connected to the plate of one of the 6L6 tube sockets. So we're getting 469 volts DC. Okay, now if I disconnect that, you can see it's saying 0. If I go back to my negative voltage supply, it's saying 57 or negative 57 volts. So it's looking like it's checking out okay. My plate voltages are within spec. My negative bias is within spec. So now we turn the amp off completely, and it's safe to assume that we can plug in some tubes. Alrighty, so I've just plugged the brand new tubes into the amp now that I've tested out that the bias works and all that stuff. I thought I'd have a little poke around, and it was time to measure the bias with the tubes in there, make sure that the amp is working correctly. And one of the things I had noticed that in the bias circuit here, there's a 22 kilo ohm resistor here, and it's not standard. So I thought I'd double check and make sure according to the schematic that was correct. I found some circuits that were 15 kilo ohm, found some that were 10, some that were 22, some that were 33, etc. So I wanted to make sure that was right before I really turned everything on and made it work. I am going to show you my calculations. So come over here to my laptop. Now what I have over here is a little bias calculator I've put just into Google Docs. Up the top here I have it for cathode bias. So this is calculating for cathode bias amps, and down here this is for fixed bias amplifier. So the first thing I did with the amplifier switched off is I measured the DC resistance between the plates of the tubes and where the red or B plus is coming from our high voltage. How do I check that? Well, I basically get my resistance, my multimeter, and I set it to resistance. Usually the 200 ohm setting is fine, because what I find is that so see where this lead is plugged in here, you've basically got one side of the standby switch. That's essentially connecting your B plus coming from your capacitors, the filter caps. So it's your full 430 odd volts, 440 odd volts. So the other end of your lead goes to the brown wire or the blue wire, which is going to or the plates of your 6L6s. Now, because there's only two wires, they'll only go to two of the tubes. Normally it'll be one of these pair here, one of these pair here. Let's see if we can kind of see where they're going. So you can see here there's that blue wire and it's going to the plates here. And down here on this tube you see the brown wire going to the plate here. So essentially what we're doing then is measuring the voltage drop. The difference between the full B plus and then the B plus that you're getting on the plates there. And normally, because that's going through the output transformer, what you're getting is a little bit of a voltage drop. Now that voltage drop, if I come back over here, you can see there the second line, VL voltage drop, which is left side, and VR is right side. And I've also color coded them. I should probably change the green to brown, but you get the idea. Blue is blue, that tends to be standard, and the other one's whatever color. So you'll see that the voltage drop here is very similar on each side. Now what I did, even though I've bought a matched quad pair of tubes, here's what happened earlier, and I didn't capture this on video. The numbers, not only on this side, so see how these two numbers are different? That tells me the output transformer, even though it's pretty close, each side of the output transformer, the push-pull, is slightly different in ohms, in resistance. And that's enough to often change what happens further down here. So if we look here, what we find, and I had to swap some tubes around to make sure the numbers were correct because they never match perfectly. I've got a 1.65 volt voltage drop on the blue side and a 1.67 voltage drop on the brown side. When we calculate this, which is essentially taking the plate voltage that we measure, 139 volts DC in this case, we times that by the milliamps, in this case 43.54 milliamps, and I'll show you how we get that in a moment, and that gives us the wattage. So how do we get this milliamps down here? Well, what we do is we take the voltage drop, we divide it by the resistance that we measured on the same side, and then to get it in milliamps, we times it by 1,000, or you can not times it by 1,000 and just move the decimal places across yourself. And that's about an approximate. And you can see each side is roughly about the same. So 43 milliamp on one side, 46 milliamp on one side. What that equates to in wattage, so what you do is you take voltage times current. Okay, so 439 times that, and it equals 19.1 watts. Now on the other side I'm getting 20. And I've also calculated the percentage. Obviously with most of these amps, we look here, I've got it 70%, and all these calculations, I want to aim for 70%. So you look here, I've got 63 and 68. Well, that's damn near close, and you never want to go over, It's always best to be under. So I'm going to leave this amp alone. It does not need any bias adjustment. I can fiddle around with the balance pot if I want to get these even closer, but 19.1 watts and 20.5, I'm not going to get much closer than that. The next thing I do, which I look at the amplifier, I'm looking at the valves every now and then. What I'm checking for is red plating, and I see none of that. Okay. A little bit of heat coming off them. The amp is not on standby, so it's on and in playing mode. Actually, and what I'll do before I turn the amplifier off, I'll just show you the waveform that I'm getting out of it. So what I'm going to do is, this is a master volume model, so I'll turn the volume on channel 1, the normal channel, up to halfway. And what I'll do is I'll slowly turn the master volume up to an acceptable level, and we'll have a look down here at the oscilloscope for a nice clean signal. So I'll just adjust that sync slightly. Now you can see a bit of a wave there. That's just my camera being a bit of a nuisance. But you can see there's the noise floor, and that's, if I turn up the sensitivity, okay, you can see that's a pretty quiet amp. And I'll grab my chopstick in a moment and do a bit of a check on other bits of this amplifier, but you can see that there's quite a bit of amplification, but I've set this oscilloscope to a very sensitive level, so once this goes into the cabinet it'll be shielded and it'll be even quieter than that, so we won't have to worry about all that stuff. But you can see here it's a nice clean signal. Yeah, it's working beautifully. So I'm going to pack things up, put it into the cabinet, and give it a test run with the speakers connected and see how it goes. But looks like it's all safe to operate. Bias is in spec, everything's happy, and we'll see how it sounds in the amplifier. Alright, so I've just about put this Fender Twin Reverb back together, and I noticed a couple of things. It sounded like arse. And I'm just waiting for my soldering iron to warm up because I'm going to try something with it. So the speakers in here are brand new. They're brand new. They're brand new replacements. They're not the originals, and that's fine. But they sounded like crap. They sounded like they were farting no matter what note I played. And there was no volume. And I started thinking about it. And I called the customer and I spoke to them and I said, look, it's sounding better than it was before because, you know, new tubes, new caps, new resistors, it's all biased, everything's great. I did plug it into a separate 4-ohm cabinet and it sounded insane. It sounded like a Twin Reverb should. And the first thing I notice, I'm about to pull the speakers out. I even removed this bottom panel here to get access to the speakers a bit easier. And I was about to rip them out, and I noticed two things. One, which I've thrown away now, were these blobs of solder that were sitting inside the speaker cones. There's one still in there I'm going to try to carefully get out without damaging the speaker cone. So whoever has soldered these wires back in has done a tidy job to begin with. Not only that, the second issue, which I'm hoping is about to fix this flubbery lack of volume, is that the speakers are actually wired out of phase. And let me show you what that looks like. So these are two 8-ohm speakers that are wired in parallel. We can tell they're 8-ohm speakers because it says so. It's a C12N, it's a Jensen speaker, 8-ohm. And this one down here, where is it? C12N, 8-ohm. So they're both the same speakers. But let me show you what's going on here. So we have a brown wire, that's positive. And we have a cream, we'll call it white, wire, that's negative. And we can see that here, look. There's a positive symbol on this side and a negative symbol on this side. And we're going to follow the negative wire that's connected in parallel to the other speaker. And I don't know if you can see that, but that's a positive symbol and that's a negative symbol. the speakers are wired out of phase. Not only that, this wire is actually pivoting right here. So I'm gonna remove these two parallel running wires, these ones here. I'm gonna remove them completely. I'm gonna cut off the ends. I'm gonna re-tin the ends with brand new solder. I'm gonna clean all these big blobs of solder up. And then I'm gonna twist these, just like this is. And I'm gonna put it back together. And then we're gonna test the amp out again. Now here's the thing, I would like to show you what it sounds like, but I found that I recorded it and I listened back to it and it's just distorted. I'll try to capture the sound of this when it's fixed. The reverb working there, and I'll turn the reverb all the way up. So I'll put the reverb down to a reasonable level. Alrighty, and tremolo. So I'm just using the foot switch down here. We've got speed coming up. And intensity. Uncle Doug would be proud. That's quite quick, and get it quite slow. And you'll remember previously there was a capacitor I changed over. It was the 5 microfarad 50 volt, one of the white little Mallorys. I changed that over. I couldn't find a 5 microfarad version that would work, so I put in an 8, hoping the tremolo circuit still works. And you know, the phone always rings when I'm recording. I edit that out quite a lot, but there you have it. Anyway, ladies and gentlemen, the customer is coming over this afternoon. He's going to be very happy to pick this up. All I want to say is thanks everyone for watching. I really appreciate all the support. I know my videos aren't amazing. You get guys like Uncle Doug and D-Labs and Mr. Carlson's Lab. I watch those because I love playing with this sort of stuff. I'm not an expert like they are, and you know, I do this kind of in my spare time between gigs and between tours. So it's something I just do as a passion. But I do want to say I appreciate and love the support that everyone gives me. That's pretty much basically it. Yeah. Anyway, guys, see you next time.